Hi students, very good afternoon to all. My name M. Shekhar, Assistant Professor, Department of Mathematics. Now, today going to discuss about fluid dynamics. Fluid dynamics introductions and basic concept of fluid dynamics. What are the basic concept of fluid dynamics using in real life? Now, first one is mechanics. Mechanics is a oldest physical science that deals with both stationary and moving bodies under the influence of forces. Mechanics there are two types. One is statics and dynamics. Statics is the mechanics that deals with bodies on the rest. That is, the particle rest mode is calculated for the bodies are calculated. That is called a statics. The bodies are rest. That time is calculated. The particle now there is called the statics. Dynamics. The dynamics the branch of deals with bodies and the motion time. Now there fluid mechanics. The science that deals with the behavior of the fluid at rest, fluid statics or motion, and the interactions of fluids with the solids or other fluids at the boundaries. Now, fluid mechanics is referred to the fluid dynamics by the considering fluids at rest as the special case of motion with a zero velocity. For given velocity, the example of fluid mechanics deals of the water flow. Water flow deals with the liquid or gas and motion are at the rest. That is fluid dynamics. Now, hydrodynamics, the studies of motions, the fluids that can be approximated is incompressible. The incompressible flow is a liquids or water or gas and low or high speeds. Hydraulics, the subcategory of hydrodynamics which deals with the liquid flows in the pipes of open channels. Next one is gas dynamics, deals with the rate of flow of fluids that undergoes significant density changes, such as the flow of gases through the nozzles at high speeds. Aerodynamics, the aerodynamics deals with the flow of gases, especially of atmospheric air, over bodies such as aircraft, rocket, and automobiles at high or low speeds. That is called aerodynamics. Now, another part of fluid dynamics is metrology and oceanography and hydrology. That is neutral occurring flows. Next, what is fluid? The fluid is a substance in the liquid or gas space. A fluid is consisting the resist and applying the shearing stress by the deform. The fluid deform continuously under the influence of the shearing stress, no matter to how small. In the solid, stress is proportional to strain, but in the fluids, stress is proportional to strain rate. When a constant shear force is applied, they eventually stops deforming at some fixed strain angle, whereas the fluid never stops deforming and approaches a constant rate of strain. Now they are given an example of that figure. The deformation is the rubber block, the placed on upper and the lower. The parallel to two plates passing through on. Now the upper plate is a contact to area and below is a shearing strain of calculated to alpha. Now two parallel plane is define the shearing stress tau equal to force divided by area. The force are moving the flow, the calculated opposite shearing stress act on the upper plates. Now stress. Stress is a per unit area. There are three types of normal stress, shear stress. Normal stress is a normal component of the force acting on the surface per unit area. Shearing stress is a tangential component of the force acting on the surface per unit area. What is pressure? Fluid. The normal stress in a fluid at rest is called a pressure. Zero shearing stress. A fluid is at a state of zero shearing stress when the walls are removed or a liquid container it is tilted. A shear develops as the liquid moves to a re-established to horizontal free surface. Liquid or gas. Now they are given examples of the liquid or gas. Liquid, if you take the water molecule, the group of molecules can move related to, but volume is remain relatively constant because now the surface is larger container in the gravitational field is The liquid take the space of container. Gas is expanded to unit encounters that vast container and fill the entire available space. Unlike the gas, it does not form a free surface and it expand to fill the entire available space. Is that are examples of a solid, liquid, and gas. First one. A is should be is main at molecules are relatively fixed position of the solid. The second one, group of molecules moved about each other liquid space. That is liquid. Now third one is spread to the molecules move about of the random of the gas space. That is 3A and B and C pictures are the examples of first one is solid, second one is liquid, third one is a gas. Now classifications of the fluid flows. One, the two types of classification. One is viscous flow and inviscid flow. Viscous flow, the flow is a frictional effect of the signification. In viscous flow is a particle interest. There are region where the viscous force are negligible small compared to inertial or pressure force. Now internal versus external flows. The flows are external flow, internal flow. External flow in unbounded fluid is called an external flow. Unbounded flow is called the internal flow. The water flow pipe is internal flow. Air flow over ball enter the flow. And the flow is liquid in the tank is called an open channel flow, that is only partial filled with the liquid and there is a free surface. Now compressible, again the two compressible is used in the gas. One is incompressible flow, another one is compressible flow. Compressible flow, if density fluid change the during for a high speed of the gas flow, that is called the compressor of the flow. Incompressible flow is a fluid nearby the constant throughout. For the example, liquid flow is called a incompressible flow. Gas flow is called the compressible flow. A gas flow is a highly speeded gas flow is a container to bounded space. Incompressible is a open space. Now is a March number. Compressible flow is calculated by velocity or speed of flow divided by speed of sound. Now for given example, the children's imagined spherical shock wave produced the bursting balloon at the Penn State Gas Dynamic Lab. The several secondary shocks are seen, the calculated to equal to 1 sonic flow and less than 1 is a subsonic flow, greater than 1 is a supersonic flow, greater than or equal to hypersonic flow. Laminar flows and turbulent flows. The laminar flow, highly ordered flow, is characteristics by the smooth layer fluid, the fluid of highly viscosity with such as oils and low velocities is typical laminar. The laminar flow is a smooth flow, is called a laminar flow. Turbulated flow is highly disordered. The flow is moving the disorder. The fluid motion that typical occurs high velocities and is characterized by the velocity in fluctuations. The flow of low viscosity fluids such as air at high velocities is typical turbulent. The transitional flow, the flow that alternate between being laminar flow and turbulent flow, in between gap with the flow is moving, that is called the transitional flow. Now steady, unsteady flows. Steady flow, what is that steady flow? The stream implies no change at the point with the time. The opposite steady is unsteady. Steady, the point which perfectly at the point is doing the work is no change of the point, that is called steady point. Opposite to the steady is unsteady. Uniform flow implies no change of locations over the specific of the region. Periodic flow, the periodic refers to kind of unsteady flow which of the flow is oscillated about the steady mean. So thank you.